Hello everybody, this is a snapshot worksheet on the central limit theorem. It is assumed that 1, you are familiar with the normal distribution, how to work with the standard normal distribution, in particular taking a distribution and converting over to the standard normal distribution by utilizing the z-score formula, right? You subtract the mean and you divide by the standard deviation. Now, there are certain conditions which must be met in order to convert over to the standard normal. Once again, it's assumed that you're familiar with that. For example, you can always convert a regular normal distribution to the standard normal distribution. Okay, we saw that you could approximate a binomial distribution using the standard normal distribution. All right, so a quick reminder of what the central limit theorem is about. For a given sample size, the distribution of the sample means associated with the samples of size n taken from a particular population with mean equal to mu, standard deviation sigma, will be normally distributed under certain conditions, the conditions being n is at least 30 or the underlying population is normal. The sample means will have a normal population, and that population will have mean equal to mu, which is from the underlying population, and standard deviation equal to sigma divided by the square root of n. And again, sigma itself comes from the underlying population. That is, when you look at the sample means, if you start collecting a bunch of sample means, if you look at all of that as data, this collection of sample means forms a distribution in its own right. And that distribution will be normally distributed with mean mu, standard deviation sigma divided by the square root of n. But again, this requires the underlying distribution to be normal, or the size of the samples have to be at least 30. Now, here's the key here. As with any problem, you need to be able to identify the problem. The central limit theorem is used to answer questions about sample means in terms of their probability, okay? All right, so when you have a question about a sample mean and the probability the sample mean is something or in some range, you need to think in terms of the central limit theorem, because from that you can get, let me see what I can do here in terms of getting to my marker. You can find the mean is the same as the underlying population, but the standard deviation of the sample means is sigma divided by the square root of n. All right, so let's get right to a problem. Once again, you are encouraged to stop the video, work the problem. All right, so read the problem here. I'll give you a minute. No, you need to stop the video, right? Because we got to keep this video going here, right? All right, if you look at this, we want the probability, the mean lifetime of a sample will be less than 23.8 months. That is, we want to look at answering the probability that X bar is less than 23.8. Since this is a question about the sample mean, we know the following. We know the mean associated with X bar is that for the population, 24.3. We know the standard deviation of X bar is sigma over the square root of n. In this problem, sigma is 2.6. In this problem, n is equal to 33. If you do your calculations, this comes out to be 4.5260. Okay, just keep in mind, I went through these numbers, hopefully they're correct, but if there's a particular error, just let me know. All right, so now the fact that I know that X bar has a sufficient size of sample size, at least 30, I can go with the central limit theorem, and X bar is normally distributed, and it has mean and mean equal to 24.3, sigma equal to 4.5260. So now I need to get to the table. How do I get to the table? The table formula is subtract the mean, divide by the standard deviation, right? Well, in this particular problem, the mean is 24.3. The standard deviation is 4.5260. Okay, that's a 0. Now, if you do your calculations right here, I did mine, and my calculation turns out to be negative 0.11. Now, I rounded. Okay, I'll let you know because the table only goes out to 2 places, right? All right, 2 decimal places. So now I know this is the way the table works. If you look up minus 0.11 in the table, you should find that that percentage of data below this is 0.4562. And this is exactly what we're looking for. The percentage of data, or the probability of being below this particular number, which is hence the answer to the question. The probability that sample mean is going to come out below 23.8 is about 45%. Okay? Now we're going to move on to the next problem. But again, look at these problems, and each problem has to do with the probability of the sample mean. We know that under certain conditions, it will be normally distributed. Since it will be normally distributed, as long as we know the mean and the standard deviation, we can get to the table, right? Okay, again, you should be reading the problems, trying to work them out, and then watch the video. If you're not, and you're just trying to mimic me, well, it's not going to work out. All right, this problem here, once again, what are we looking for? We're looking for the probability that the sample mean for this sample here is between 1,980 and 1,990. Okay? That's what we're looking for. From the problem and the central limit theorem, okay, we know that X bar has a mean that is equal to 2,000, right? We know that X bar has a standard deviation equal to the standard deviation in the problem, 187. No, let me fix that. 187.5 divided by the square root of n. N is equal to 50. Okay, so once again, I should be highlighting this. Here's the mean, standard deviation of the population, but we want the standard deviation of X bar, and we have to divide by the sample size, or the square root of, right? If you do the math, you're going to find out that this is 26.5165, okay? I like to keep at least 4 places, and in fact, some problems you even have to keep more, but in general for us, 4 places should be good. Now, we know from the central limit theorem that the X bar will be normally distributed under this situation. So once again, we're going to get to the table. And the way we get to the table is by subtracting the mean, dividing by the standard deviation. We're now at the table. Subtract the mean, divided by the standard deviation. When you do your math, this becomes minus 0.75. This one on the right becomes minus 0.38. Again, you can always stop the video. Now this is the third scenario where we're between two numbers. So when you look up your numbers in the table, when you look up in particular minus 3.8, you're going to find 0.3520. When you look up minus 0.75, you're going to get 0.2266. All right? When you take the difference between these two numbers, you get your answer, which is 0.1254. And there's your answer. That's the probability that for this sample, it comes out, the sample mean comes out between these two numbers here. All right, moving on to the next example. And again, you should be working it out. Just let me know. Again, I work these out, but you never know. Okay, I did them pretty quickly, but just let me know. All right. So let's move on. Next one. All right, working out, start the video up again, right? But again, another question about the probability of a sample mean. And in the first one, we want the probability that the sample mean is, well, actually, I'm going to have to make a correction here because I fixed this one. I wanted it to be greater than 65, okay? So that's going to be greater than 65, right? All right, so anyway, I need to fix that in my document, but I have it on paper here. I actually wanted that. All right, so anyway, so we're looking for the probability that X bar is greater than 65. Once again, if you look at the problem, the underlying population has mean 68, standard deviation 10.1. The sample size is 45, so it's large enough so that we know that this will be normally distributed. The only thing we need to know is what the mean for X bar is, right? Well, that's just the mean of the population, 68, from the central limit theorem. We need to know sigma of X bar, but from the central limit theorem, that's sigma over the square root of n, right? And sigma is 10.1. N is equal to 45. Do your math, and after you do your math, you're going to find out that sigma turns out to be 1.5056. So now we switch this over to the standard normal table by the conversion formula. So this is equivalent to the probability that Z is greater than 65 minus the mean divided by the standard deviation. If you do your calculations, that's the probability that Z is larger than negative 1.99. This is the second scenario. The second scenario says that the probability of Z being larger than the number is 1 minus the probability of being less than the number, which when we look up in the table, minus 1.99, we get 0.0233. When you do your math, you get 0.9767. So there's almost a 98% chance that the sample mean is going to come out to be above 65. Okay, moving on. The probability of the class mean is between 65 and 72. So again, we're talking about the probability of the sample mean. If we're talking about the probability of a sample mean, and inequality signs don't matter because We're working with continuous distributions here. Well, once again, we can utilize the central limit theorem and look up the probability that, subtract the mean, 68, divided by standard deviation, z less than, subtract the mean, divided by the standard deviation. It's supposed to be a 5, 6, okay? All right, there it is right there, okay? All right, well, when you do your calculations, this turns out to be the probability that z is between minus 1.99 and 2.66. Well, then, again, this is the scenario where you subtract the smaller percentage from the larger percentage or probability, right? Those are the two numbers you're going to get from the table. When you do your math, you should get 0.9728. Okay? Now, if you were an instructor and your mean grade was 54, what would you conclude? Well, basically, I put these kind of questions out here because they're sort of open-ended in the sense that subjective, because it would only suggest that you should look at the test. Maybe something was wrong. Maybe how did you present in the class? A lot of things you should just look into it, because if you look at the percentages above, the probability of being above 65 is almost 98%, okay? And so it is highly unlikely that your grade should be below on average below 65. So it warrants investigation. That's all. That's all I'm trying to point out, is that that's what this is actually utilized for. A lot of times is to get a feel for if something's changed or if something is different, right? All right, so that's, I think, the last question here. Again, just let me know. I know I have to correct this little mistake right here. Okay. Again, it should be corrected on the worksheet itself when you actually see it. But anyway, good luck, and see you in the next video. Okay.